Thank you very much for joining the event. Welcome to the event. I'm Matteo Carizzi. I'm an associate professor in the Department of Psychological and Behavioral Science, and I'm also chairing the LSE Open Research Working Group. And I'm going to chair this event before presenting the fantastic panelists for today. Let me spend a couple of minutes on the LSE Open Research Working Group initiative, which is an informal group of academics, professional staff members, and researchers at LSE to provide strategic direction to support open research across the different disciplines at LSE and to foster a culture of open, transparent, and inclusive research at LSE. The LSE Open Research Working Group is also acting as the local network of the UK Reproducibility Network. And the initiative of the LSE Reproducibility Network was started in 2019 by Heather Capps, Dario Kpan, myself, and other colleagues, and have been revamped and relaunched thanks to the help and support by Rosie Igman, Lucy Lamb, and colleagues at the LSE Library, as more recently, last July. So as part of the initiative of the Open Research Working Group, we are actually promoting events like this one. This is the second event of the year, following an event on publishing a couple of weeks ago, chaired by Liz Stockwell. A couple of information about the Open Research Working Group. We are actually still looking for colleagues at LSE that want, if you want to participate or contribute to the Open Research Working Group, please reach out to us at the end of the event, or talk to Lucy or myself or Rosie, and we will be very happy to involve you. So as far as I know, there are no fire alarms planned. So if there is a fire alarm, it's a real one. So the assembly point is outside Cooper's in the CKK building. And also, please put your mobile phone on silent mode. The event will be recorded and we will make it available on the Open Research Working Group webpage. I'm really delighted to welcome and introduce the three fantastic speakers for today. There has been a change at the last minute. Yesterday, Philip Schoeniger, who is a research officer at the Behavioral Lab, who was supposed to come in the panel, unfortunately could not make it, but we have a fantastic replacement. And I will start with Dr. Sanchayan Banerjee here, who is a senior lecturer and associate professor at in economics and public policy at the Policy Institute at King's College London, so nearby. And also Sanchayan is a former PhD student from LSE. He graduated recently, and then he joined VU, University of Amsterdam. His main research is, he will tell us a bit more about the research, but is creating and designing participatory intervention for behavioral public policies, and also to test them using experiments. And he also has published a few papers on making behavioral policy, public policy, more plural, more inclusive. Thank you very much for joining the panel, also with such a short notice. Thank you very much. And also our contributor today is Dr. Sakshi Ghai, who is an assistant professor in the Department of Psychological and Behavioral Science. And she previously was in the Internet Institute at Oxford, University of Oxford. She's working on two main aspects. One is related to testing the impact of the new technologies on the young people well-being, and the other one is related to meta research in behavioral science with the ambition of making behavioral science more diverse. So thank you very much and welcome to the panel. And last but not least, to join the panel is Dr. Dario Krpan, who is an assistant professor in the Department of Psychological and Behavioral Science. Clearly, the department is very well represented today. And also, Ryan is actually a visiting fellow at the department. Dr. Dario Krpan got a PhD from the University of Cambridge and at the intersection of cognitive and social psychology, and is actually working on studying transformational behavioral change in the area of new technologies and development and sustainability. And so the three, thank you very much, Dario, for joining. So the three speakers are very leading experts in their field and also bring very interesting perspectives that will hopefully help us to unpack this growing interest on reproducibility in the age of artificial intelligence. Let me start with asking each of the panelists to say something about their research. We can start with a few minutes talking to each of the panelists, and then we will open up for questions. But the first is to ask each of the panelists to say something about their own research and how the research relates to reproducibility, AI, or maybe both reproducibility and AI. Who want to go first? Thank you. Yeah.
How did I get
I don't know.
Okay, I'm happy to start. Hi, everyone. Thank you so much for inviting us to the panel. So my research sort of sits at the intersection between meta science and then looking at the applied side of sort of this impact of digital technologies on young people's well-being. So in the first strand, and actually it was very interesting while preparing for this talk, I sort of started looking at my recent paper where we're trying to sort of really reimagine open science and what even open science means, but from the perspective of low middle income countries. So how open science needs to be made more equitable, more inclusive, and really rethinking a lot of the things that we take for granted with open science, particularly adapted to those contexts. And I opened the paper hoping to find what I had written about reproducibility. And it was not surprising that actually there wasn't much about reproducibility. And to really set the stage of why, I think one of the biggest challenges in psychology, alongside reproducibility, is also this lack of generalizability. And then if we apply that to the context of open science, there, really, when we are trying to sort of increase the diversity of our research samples, we're trying to sort of fight for more research diversity in our research samples, then that really begs the question of whether reproducibility in that context becomes a secondary concern, because first and foremost, we need research from those regions, and then we can start talking about whether they reproduce or not. So I think that was sort of a very interesting realization for me as I was starting to prepare for this. But on the applied side, because I'm starting to look at the impact of emerging technologies, a lot of my PhD and postdoc work focused on social media, a little bit on online gaming, and early this year I started to think about how AI would influence and impact well-being and particularly online safety of children, and in that also encountering another challenge. So I think you're going to hear a lot about challenges from me rather than any solutions, but the challenge really was that actually studying something like online harms, which I did, particularly online child sexual abuse and exploitation, which is something very much on the rise, and thinking about how AI can either help, either prevent it or exacerbate sort of it. One of the hardest things is actually finding data, and firstly, what constitutes its AI is in and of itself a big question. Are we talking about LLMs? Are we talking about predictive AI? Are we talking about data sets? And then secondly, in some of these emerging issues that AI is bringing, it's becoming quite hard to find data sets and find AI data, if you will. So either you go to law enforcement agencies, from my field of work, who routinely use AI to, detect who among the population is sort of trying to either generate images of child sexual abuse or catch perpetrators. So just to give you an example of actually what is AI and how do you really go about studying AI is one of the biggest challenges I am facing as I'm thinking about applying it to young populations and in this very niche area. So that's sort of me grappling a little bit with both reproducibility and AI, and then I'm happy to hand it over to you, Dario.
Thank you.
Thank you.
Okay. So I will talk about my research, but more in the context for I previously did AI. And as Matteo said, one of the areas in which I'm interested is new technology and how people respond to technology and change in response to technology. And one way I've been using AI, I've been using predictive AI to find the best predictors of how people respond to technology. So what does that mean? So let's say I would measure, 75 different personality traits, and then I want to see which one of these traits is the best predictor of how people respond to robots. Now, if you look at in machine learning and technology, typically the interest is we want to, take digital footprints and see whether we can predict, personality with digital footprints. And then the interest is, I will fit, a lasso regression model, and we will see whether this model, generally speaking, predicts personality well. My interest is not necessarily the entire model, although I have to compute the entire model. My interest is really in how the specific feature of this model predict specific dependent variables of interest. In this case, I applied it, for example, to how people perceive robots. Now, when you do this, you will see why replicability is very important, because you can, fit 10 different models, and these 10 different models will always tell you that some different predictors are more important, so you rarely ever have consistency. So that's very tricky in machine learning. And also, of course, different models will give you different predictive power, but even more variability will be in terms of predictors. And the way I deal with it, I typically, I would take 10 most common models, I would fit all of these models, and then I would take only the predictors that kind of occur, in the top 10 across all these models. And this way, I am sure that regardless of what I do, I always have the most powerful predictors, so it's not something that just occurs in one model but not in the other. I basically try to, that's my way of dealing with all this variability, so fitting all models and taking something that basically occurs in all models. And I think in psychology we haven't yet necessarily had consistent way of dealing with this. How do we actually ensure replicability and select the best predictors? But I think there will be some standards will probably come soon in the future. So that's one way in which I use AI, that's predictive AI. Recently I've also been using generative AI, and this is in the context of creating synthetic research participants. So the idea is that basically you can tell GPT or other large language models to respond to a survey similar to how a person who is, let's say a woman, 25 years old, who has a PhD, blah, 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 similar to how she would respond. So in this case, for example, one approach is you collect a normal sample, you collect a sample of real humans, and then you, of course, measure their demographics and some other characteristics that may be of interest, and then you feed these characteristics to GPT, and you ask it to respond to the same survey questions as it to basically replicate each of these individual humans. And there have been more and more research has now been done in this direction to see whether synthetic participants can be similar to humans. And one kind of consensus is that typically correlations tend to be quite high. So if you ask GPT to respond to a certain question and then you compute average GPT responses to the questions, and average human responses tends to be quite high correlation, like 0.8 and above, and slightly less for non-weird countries. There it could be still strong, but maybe between 0.6, 0.8. I did one research on policy relevance questions, and we had USA, Saudi Arabia, and UAE. And the correlation for US was the strongest, UAE a bit, and KSA a bit weaker, but still strong. So these are some kind of variabilities. Where synthetic participants are not necessarily great is if you want to very specifically replicate, let's say, whether an intervention will have a significant effect or not. That is still not that precise, at least to my knowledge. There have been some papers that did manage to replicate the effects, but it's variable across papers. But yeah, so that's kind of where I've been using AI.
Thank you. Sinchai?
Yeah, thank you. Well, I am a mixed bag, so I've been fortunate to work with good people all my life, so I sort of tap into whatever research they're doing. I think my first introduction to reproducibility was actually through Matteo, because he was also one of my supervisors. And then he invited me to work on this replication project for a large project they were running called Trust Lab, where effectively we had to replicate lab games to see whether determinants of trust and these lab predictors of trust would also pan out in the field. And that's when I sort of started working on one of the first pillars of reproducibility, which is generalizability and replication. We did find some very interesting findings there, of which most self-reported questions of trust were actually very bad predictors of trust in the field. We just found one, I think, which is if you leave a wallet, find a wallet, the trust wallet question, that seems to correlate very highly with findings in the field, if I'm not mistaken. And that's how I sort of started. Of course, from then, I also brought it back to my own research. I replicated many of my own sort of papers in other settings with prolific and other samples, either in the field. And then a few years ago, when I moved to Amsterdam, one of my first PhDs, he was working on a synthesis project. I asked him, hey, go and find out which of these data sets are available. And of course, of the 500 papers he found out, 499 had said data is available upon request. The request was never answered. So at the end, we had 4 people who answered the request. And that led me to a quest of open science and how can we actually make data easily available. And then when I met Saakshi, I think we also worked a bit on diversity, thinking about integrated experiments, these large-scale experiments which are run at par. We published something in Brain and Behavioral Sciences, thinking about, you know, if you can't make experiments only integrated and mega, you also have to sort of think about the diversity of the sample that goes into this. So yeah, on reproducibility side, it's quite varied, my work. On the AI side of things, this was sort of the major work I took on when I was in the Netherlands. I lead one of the largest consortiums there, Align for Energy. The goal is to mainly use predictive AI to personalize behavioral interventions and come up with tailored nudges. And the findings there have been quite interesting so far. So I focus a lot on computational social science, mostly also working with Giuseppe Veltri, who's a methods person at Trento, now moving to Singapore. We have a new paper actually coming out in Frontiers in Behavioral Economics, and we provide some sort of nomenclature of how to go about these predictive AI. We classify them into top-down and bottom-up. Effectively, you can approach this in 2 different ways. Bottom-up is where you first sort of collect a lot of characteristics about people, then you create what we call behavioral phenotypes, which are sort of these different clusters through different clustering mechanisms. I also have another review paper where we sort of show what these clustering mechanisms would look like. And then you sort of tailor your interventions adaptively based on which cluster you think would suit which intervention. To just give you an idea, if I am a myopic person, for me a different kind of nudge would work better versus if I am someone who doesn't have information. So then I just need salience. So this allows us to understand a lot about these behavioral features of people. But then oftentimes you can also use top-down, which is you first sort of let the interventions run loose. Typically, we have focused a lot on average treatment effects, but then what we do is we use these new sort of computational methods like Bayesian learners, X-learners, meta-learners, random forest models, ideally to create subparts of these population and look at local average treatment effects. So we capture the heterogeneity in each groups. So we look, okay, which intervention is effective in which subgroups of population. And then using machine learning algorithms, mostly with the work of Susan Ethi, you can create adaptive experiments. So the idea comes from medical trials, where basically you put people on different pills, you observe them at a point in time, and then you rejig them randomly and reorganize and give them different pills. So a lot of my work currently focuses on sort of experiments, trying out some of these methods, and also the interconnection of replication and AI.
Fantastic, thank you very much. A very exciting introduction and overview to the topic. Before opening to a question from the audience, let me ask you a question which goes quite at the core of the relationship between reproducibility and AI, if I may. And how would you do you think you can reconcile the two different features in a sense here? So on the one hand, reproducibility, which is aiming to make social sciences more generally open, transparent, fully reproducible, and so on. And on the other hand, the ambition to use AI increasingly in social sciences for very good reason, of course. But when it comes to social sciences, an obvious area of application in AI is to use what you mentioned, large language models, for example. And if we look at the large language models, it's true that some of the models are actually open or even open source. Think about Meta, Llama, or Google Gem or Gemini. But the frontier models are actually proprietary models. They are basically black boxes which are very difficult to reproduce, and actually they keep on evolving in real time. So basically it is even impossible to reproduce over time the prediction that were done, for instance, a few weeks ago. So what is your view on this issue? I mean, it's a question about probably trade-offs, which is coherent with the School of Economics, if you want. But, yeah. Actually, yeah, please.
So I'll possibly sort of try and articulate trade-offs try and articulate three trade-offs. I think the first for me, and I really can't stress on this enough, which is how diverse even the data sets that AI is trained on are. And I think we really have very little sense of where we are with that. I mean, I know that ChatGPT study, which showed that actually the responses of those humans are also very weird, even though I don't think that's the most accurate label often, but I think the challenge of LLMs that have been trained on masses of data, which don't accurately represent the world's population, and what does that mean for reproducibility downstream? And I think I really wrestle with that question. And I don't have an answer, but I really do think that reproducibility as much of in and of itself is a hallmark of scientific credibility and is going to become increasingly important in the age of AI. We can't ignore the fact that there are certain biases, stereotypes, which may lead to things like overfitting models or, excluding diverse demographics and leading to sort of inaccurate predictions. And, it's like, especially in medical and health sciences, the costs of that would be very high. So I think that is one. I think the second is really, and I think you painted the trade-off really nicely to highlight how actually, on one hand, we do want it open, but on the other hand, these kind of things are not open, and that touches upon even a deeper question of who gets to reproduce. And again, as I was sort of trying to even think about things like computational reproducibility, and bear with me as I use this analogy to illustrate how challenging it is to get equitable access to software, to resources, to computational training, is, when thinking about sort of like, now of course we're in 2024, we have so many new LLMs, the modalities of AI are changing. We started with LLMs, now we're at images, videos, all of that is going to change rapidly in the next decade or so. But if we go back to 1960s, when humanity was thinking about the first lunar launch, and we were trying to get us into space, and if you think about the computational power at that time, I think it's compared to something like a cell phone or a calculator with 72 KB, and I was absolutely shocked to hear that, because today that's like the equivalent of a Word doc or an Excel file, if that. And that really highlights actually the complexity of models today and how much software, and even sometimes even how much software goes into into computational reproducibility, and as computational social science gets more sophisticated, it gets back to the question of A, who has access and who will get access, and B, sort of sustainability, and in trading off reproducibility, in thinking about reproducibility in the age of AI, and especially thinking about the long-term impact, and shouldn't we consider also sort of this trade-off, and and then particularly sustainability, but also ethical access to people around the world who don't typically have. I mean, some of these softwares are behind closed doors, and even though there has been a greater push towards openly accessible LLMs, openly access databases like OpenAlex, there still sort of begs the question of who gets equitable access. And I think those sort of are the two really main things that I sit with or struggle with in thinking about this trade-off. And the third thing I just want to very quickly add, but not expand on too much, is that as we think about the future of AI and reproducibility, I think realizing that how much of that is going to just change and how much of that is already changing, like I said, with new modalities, and how we are actually trying to figure out our stance in science and in the scientific community on AI. We started with no, we are moving to yes, maybe, potentially, and even as we sort of build our, build a robust science, and particularly we think a lot about psychological and behavior science, how can we recenter sort of the concerns of, making sure everything is reproducible, but making sure we don't trade it off with other concerns that may still be equally relevant to improve science.
Thank you very much. Thank you. Dario or Sanjay, do you want?
Maybe I can pick up on the last point. I don't know if I have a great answer, but I have an anecdote which was very interesting to me. So Sakshi sort of pointed out in the last one how quickly moving this field is. When I went to the Netherlands, part of my job actually came with the PI of this large project. Someone else had written the project. It was a hugely ambitious project. They wanted to create an AI-driven system that would optimize and tailor interventions in the energy sector. We were working with large energy clients, commercial companies, the grid in the Netherlands. So I had all the resources. Unfortunately, the people who had written the proposal had moved on. So I was like, wow, okay, lots of money, 5.5 million euros for 5 years, great thing. All the connections. And then I realized one of the partners, because this proposal was turned in 3 years ago, and unfortunately that's how sort of slow we are in academic settings, one of the companies which was involved in the bid had actually gone on and developed the whole AI platform and was selling it on a commercial basis. So at the end of 3 years, when I had the money and I reopened the conversation with them, they said, well, you can either build it from scratch, good luck, or we can help you, but then it's no longer open source. And that was the sort of the heart of the dilemma, that effectively in this fast-moving world of AI, how can we keep up with commercial companies? And typically there is this disconnect. This is one of the observations I made early on. There's this disconnect between pace of research and also the pace of commercial sectors, driven particularly by some of these incentives. We did overcome that in a way by putting in a lot more money than we had initially thought about in developing the second version of the AI tool, on the premise that the first version would always be protected. So that never becomes, and then sort of thinking, putting on my hat of economics of innovation, I mean, this is not a new challenge we have faced. We have patents, for example, which are designed to protect and also encourage some of these developments. And increasingly, I think some of these things are being developed more, but I do think that we need to think a bit more towards patenting and sort of protecting while encouraging the AI market, given how quick and dynamic it is. Yeah, Dario?
Thank you. Yeah.
Okay. So from my perspective, just looking at the replicability of the models, given how they work, and that with LLMs, you basically, if you use the same prompt twice, you're very likely going to get different results. Now, depending on what we use it for, but my view is always to try to test a few different versions of the same model and also several other models, and then seeing is there some finding that emerges across all of these models, because that's then the finding in which I have confidence. if I test all of these models and I don't get anything that essentially replicates across the models, then I'm not very confident in the finding or in what I'm studying. And if you look at, for example, research on synthetic participants or everything that is related to prompting, it can be using GPT to help people for predictions. You typically need to do something which is called like robustness test. So you need to basically try different versions of instructions or prompts to GPT or other models to see if the findings will be aligned. So overall, as a conclusion, I think here what we can do when replicating some research with these models, we can try to use the same procedure at least as another person has used, and we can try to test several different models and versions of the same model to see whether something replicates, because I think beyond that, just expecting that we can take one model and replicate exactly the same finding, that's, I think, not very likely here.
Thank you very much. That is a series of excellent and brilliant points. The last point is talking to something where reproducibility people will call pre-registration, pre-analysis plan of AI interrogation. But anyway, it's something very interesting. But we can open up for discussion to questions from the audience in the last 15 minutes. Is there any question from the audience? Please, yeah.
I was just wondering, you were talking a bit about weird and about, I suppose, testing AI with different populations, I think, Dario, specifically. And I was wondering about the impact of talking about the I of weird, industrialize, and the impact of the training process in terms of how to use the AI models, how that would then affect the responses that you get, because you can never test someone who hasn't been trained on the thing that you're testing.
Well, I mean, so with synthetic participants, like if you mean whether people need to be trained?
I mean, like real people who have not had contact with that kind of technology before.
Because basically when we do this research, it's more like you give people like a normal survey. It doesn't have anything to do with generative AI, just like a normal experiment. And then you feed the same survey to AI. So like basically people are not in touch themselves with AI, so it's not necessarily about training them. It's mostly about the fact that AI, well, all these models are trained on a huge amount of internet data, which are mostly English speaking and are mostly representative of the United States and some culturally similar countries. And I think basically how those models respond to people from some other countries, let's say in Africa, some other continents, is more from the perspective of prejudices that, let's say, people from United States or UK have towards this country. So like if you, let's say you have a prejudice that someone from a certain region will be more conservative, or they will not be very environmentally friendly, GPT basically responds for that person in the same way. But then when you actually test those people, you get surprised. You see that they're actually, let's say, way more pro-environmental than you would think. That's very surprising, and let's say way less progressive. So it's really like GPT, some form of like Westerners, how Westerners see other countries through their prejudices. But that's why the most important development will be, let's say, training models on country-specific data and on topic-specific data. Like if you want to do something on policy, then trying to train the model on data that's relevant to policy from the country, and then seeing if this can improve accuracy. Because I mean, all these studies that we do now is like the least amount of effort. It's really just taking the model, giving it some prompts to try to think like some other person. But I think when people actually try to create specific models for specific groups of individuals on more relevant questions, I think that could improve replicability, well, not more the similarity, but maybe I'm wrong. Maybe it is the fact that GPT has huge amounts of data, so maybe it's not about specific questions, maybe just about country-specific data, because that for sure will make an improvement, but about topic similarity, that's difficult to get.
Yeah, please.
Yeah, I think on a broader perspective, I think this is also something that behavioral science has generally struggled with, context specificity, because if you look at sort of nudge and sort of the whole nudge revolution, I mean, typically generalizing most of these findings, they don't work out because most of the evidence comes from Western world with the weird context. I mean, Sakshi is an expert on weird, non-weird dichotomies and how to move beyond that. Read her Nature paper for that. No, but I think it's a big problem. And just sort of building on Dario's point, because I come from India originally, and one of the things I see is access to internet as a large limiting factor in building these models for generative and predictive AI, because access to the internet, of course, is limited to a very small segment of the population, urban, educated, rich income groups. And then how do you generalize? Even your stereotypes would be very limited to local groups of population in these countries. So thinking about building these models really needs diversifying samples, and I don't think internet would be the best form of media for that, to get access to this data.
Yes, please, we have a question there.
Sorry, maybe I'll ask my question. It's sort of related a bit to yours, but I'm interested in the challenges of synthetic participants. So apart from what you just discussed, have you come across anything else that perhaps surprised you, or something you haven't thought about that you need to have in mind if you're using synthetic participants in surveys in particular?
I mean, one thing is that when they do replicate-like effects of interventions, they produce very inflated effect sizes, like 10 times larger, let's say, than the normal one, 10 times larger than, let's say, normal research is medium one, and in some cases, and that's because synthetic participants sometimes tend to produce lower variability. Like if you have two groups of participants, they will produce way less variable responses, and because variability basically determines standard deviation, meaning effect size, so that's why effects are so big. But there are also cases where it completely doesn't give any variability. So you, let's say, have a few hundred synthetic participants, and 95% of them give you exactly the same response. Like if you have, I don't know, some Likert scale from 1 to 5, then they give you 95% of them. That's actually what they call it correct answer effect, because they think that GPT thinks that there is one correct answer, and then it always gives that answer. And in the study I did, we were experimenting a bit how to avoid it, and it's not that easy. You can use different problems, but it's difficult to go around it. But typically, it seems to happen on more like on topics like sustainability, maybe because the GPT kind of, well, understands that, let's say, climate change is real, but all people don't necessarily have the same view on that. So people are much more variable, which GPT would not understand. And yeah, so that and I mean, even there was some other study which said that, like if you ask people to give you a random number from 1 to 100 or something like that, people will on average, usually will need to have like some, it should be similar amount, proportion of all numbers, but people will greatly give you some numbers, so it will not be like a similar, it will not be similar distribution of numbers, but it will be some numbers way more than others. And GPT will not do that. GPT will give you exactly statistically how it should look like. So GPT also can't necessarily understand how humans think always in those cases, that humans, and maybe with more research, like the way to express it would maybe be that GPT is like, if it's very rational, it will try to think how humans think, but maybe sometimes in a rational way. And yeah, that's not how humans always think. Or it will not understand that humans can have different opinions, that not everyone, like even if you ask people some very obvious question that everyone should agree on, they will never agree in most cases. So and GPT will not do it that way.
So are they more likely to always give an answer? Would you get like a good rate of don't knows or not sure, like in the general population, for example? Or would they always try to provide you the GPT, for example, will they always try to provide you a substantive answer?
I mean, these will be more like quantitative responses, like, and I was asking about qualitative. If you ask them a question, quantitative, I mean, yeah, GPT is, I mean, it really depends, but usually it will have lower variability than humans. Doesn't necessarily need to be the rule, but it tends to be the case. But then the problem is always it's very difficult to understand why, because it's a huge model. It's very difficult to discover why it is happening. So
Thank you.
Thank you. Yes, please.
What do you potentially think is the time horizon for when it will be kind of the default procedure to replicate your field studies using AI to gain validity? Are we talking about a time horizon of like 2 years, 5 years, 10 years?
Very ambitious, I would say. Running a field study takes 5 years. Replicating it probably takes another 5. I don't know. I can't predict, but I don't think it's going to happen anywhere soon, given how complex it is to run field experiments. Yeah, I don't know if you guys have a better answer to this, more optimistic.
Well, I guess the first question would be field experiment where? So of course, if you're running a field experiment, could be online, then that would look very differently versus if you're talking about a field experiment in some low middle income country, which then would drastically change things. And I mean, I think it's also really interesting topics of what field experiments typically focus on in psychological and behavior science that then would lend itself to that kind of replicability, because depending on whether you're focusing on sustainability or you're focusing on, I don't know, nudge changing behaviors, that might then also add a layer of complexity in making field experiments replicate, because what really goes into losing the replicability in the field is also attention to measures. So how things may be measured in the lab versus how things are measured outside, and there's sort of lots of considerations to replicate, and that is also sort of another layer of complexity, if you will. So replication or advancing research in different parts of the world, or even if you haven't done it outside the lab, just complicates it.
I think what would immensely help is creating repositories of these field experiments, and I think this is an initiative Matteo is involved as well. I was speaking with Elizabeth Costa recently, and at the BIT now at Nesta, they're forming this large repository where they're sort of categorizing their field experiments and putting the data. And I think these kinds of exercises will take us closer to something you're thinking, because once you've built that base, that just gives you enormous amount of data to unleash the devil, as I call it, with these machine learning models, because that's what they do. They're also highly intensive when it comes to sort of the amount of data you need to feed in to come up with sensible estimates that can sort of guide you to some reasoning. Not all clustering mechanisms per se, but most of them can be quite data intensive. So if you look at the paper by Della Vigna and Elizabeth Linos that came out 2 years ago in Econometrica about scaling up sort of RCTs, they had evidence from 126 sort of large trials, more than 200,000 data points. I think those are the kind of studies we're thinking about if we're even considering, let's get closer to using AI to replicate some of this research, because then maybe synthetic participants can help.
Yeah, I mean, what is actually happening now, what I hear is that apparently people who are answering online studies, they actually just ask GPT to answer for them. so that, especially like if you need qualitative answers, so like at some point it will not even be necessary to replicate, you can just add GPT because. But joking, so this is actually happening. It's a big issue, especially like as I said in qualitative research, because there are very strong evidence that people are now using GPT. And then, of course, also I mean, humans are becoming like, will in the future people start thinking the way GPT thinks, because a lot of people are now using GPT for writing. So I guess at some point, just the writing styles. And I think there has been some research that like after GPT was developed, certain words started occurring way more in writings, which people didn't use before. So like, we are basically starting to think like GPT. I'm not saying that I am, but people who use GPT, I use it only for correcting assignments. I'm correcting them myself, but I'm curious to see like simply if GPT will be similar to humans in the future, because GPT becomes better, or because humans become more similar to GPT.
Thank you. Maybe time for a last question, and then we should probably wrap up. Yeah, please.
A quick question linked to the last reflection about cultural sustainability. So if we are converging into a world where everybody is thinking the same stuff and we are feeding the same information, how do you ensure that you are sustaining the diversity, the cultural diversity that we can see now?
I feel like it's $1 million question. No, I think that's a really thoughtful question, and I think that is one of the really interesting things that I pointed out, that actually possibly ChatGPT might think very similar to humans and vice versa. And I think that just gets really complex and really gets down to the basics of AI companies and even thinking about LLMs and where do these LLMs come from? They come from Silicon Valley, or they come from a few industrial organizations or a few people in the industry who make it. And again, what data set it's trained on. And I remember, like, even in the US, it's not representative, and even in the US, it's not able to accurately pick up on diverse perspectives and include ethnically diverse populations there, and has all kinds of issues from facial recognition systems, recognizing non-Caucasian faces in the US and just like all sorts of problems that even in the US we're still starting to identify. Maybe we're a long way from solving it. And if you then quantify, or if you try and juxtapose that problem or extrapolate that problem to the world, I think we have a very long way to go, in my opinion. And I think possibly having multilingual LLMs in regional languages, not even the country's national language. So I come from India, and the national language is Hindi, but how many languages are there in India? I would say
21 officially.
21 officially, but then regional, and then, so there's just the kind of languages that then compete. So I think possibly the future, in my provocative opinion, lies in those region-specific LLMs that might be able to even pick up on words. A lot of the English words may not easily translate. Like I struggle with studying well-being and translating depression and well-being in Hindi. Like there is no word for it, or in Cambodia there's a different word for it. So I think that's what also then further challenges. Yeah.
Thanks a lot. Thank you for the excellent discussion. Thank you again to Lucy and Rosie for organizing. And thank you very much for the brilliant talks by Sanchai and Sakshi and Dario. Thank you very much.
Thank you.